So thank you very much for being with us today. And I have to say, those moments are the moments that I cherish throughout the year the most, because it's really great to visit Asia. It's so great to see my colleagues, our customers, and being able to stay an entire day with you and with a great knowledge and wisdom of our speakers and be able to learn so much today. So this is a moment that I really cherish a lot in my working life. And those moments, standing together with Professor Linhares on the stage and talking about PRRS is something that I'm very much looking forward to.
Should be fun.
Absolutely. And Daniel has been working with PRRS. As soon as you have encountered PRRS, you know the name Daniel Linhares from the Iowa State University. And Daniel, you have been working with PRRS now for 17, 18 years? And since 10 or 11 years, you have been leading, or you are leading, the field epi team at the Iowa State University, where you accompany US swine production systems on their journey for PRRS control and help them to stabilize their herds and taking a well-defined decision based on knowledge and economics, right? And when you are guiding those production systems for PRRS stabilization, what do you think are they mostly struggling with, and what would be most beneficial for them to have to obtain?
Yeah, good question. I think working with different people from all the way from the Americas, crossing Europe, and then here in Asia, even within the countries, the solutions are going to be different for every solution, right? I don't know of any farm where you can copy the solutions from one farm and pay to the next, because then there's biosecurity, there's monitoring, the constraints are going to be different, the goals are going to be different. So it's complex in that sense, but one thing that's simple and encouraging is the questions are the same. And the procedure to identify what are, how do you get from unstable and unfavorable situation to where you want to be. Again, the path to get there is different, but the questions are exactly the same, and that's what we're going to talk about here today. Marcelo talked about the 5-step process for PCV2. We're going to here talk about this 5-step process for PRRS. So the same recipe with different answers, but the same questions, the same guideline. That's a good news, isn't it?
Exactly. So I'm very happy that we're going to share with you the 5-step for PRRS control because, yes, you have heard from Marcello, this is a process that will help you through all the disease that we are encountering. And when we talk about PRRS, you may know this is just a small recap that we are talking about PRRS 1 and PRRS 2. And those are quite different viruses. So they share only about 60% of their genome, meaning 40% of the genome are different. And this is a map just depicting where you find PRRS 1 and where you find PRRS 2. And you can see here, this morning we started with Nikolai sharing this experience from Denmark. And you see Denmark is mainly PRRS 2 nowadays. And probably when we will have our next Asian perspective or the next Asian perspective, then the color of that has probably also changed to PRRS 3. So we will track this very closely. And here in South Korea, as you can see, we have also mainly PRRS 2. The process, I think it's similar if you are encountering PRRS 1 or PRRS 2 in the system. The vaccination protocol is a little different to where you are encountering PRRS 1 or PRRS 2. And if you want to learn more about this, vote in the jukebox session for Nobody But You, But Who. And also what we have seen over the last couple of years that we have a rise in highly pathogenic PRRS strains, whereas we see this mostly occurring in Asia and in the US, where we see those highly pathogenic PRRS strains rising, as you can see here in the US, the lineage 1C, 1CA, or 1C. They have really high mortality. They're associated to high mortality here in In China and in Asia, we have mostly NADC 30, NADC 34 also associated with higher mortality. In Europe also, we have a couple of really nasty PRRS strains. So currently in Europe, we are fighting with the Rosalia strain that is causing unusual mortality, mainly in the piglets. So controlling PRRS is a program that we are encountering all over the world. And Daniel, from your experience, why do we see a rise in these highly pathogenic PRRS strains?
Yeah, so like you said, the names change across the regions, but one thing that's common is we're seeing those highly pathogenic strains emerge and rise to the top. And Marcelo can tell you more about how they look under the microscope, right, in terms of lesions. It's going to be more severe. But then to the question, how do those emerge? We know that PRRS evolves in two different ways. It evolves through mutation when it replicates. So the resulting copy of the parental virus that's replicated in the cell, it's never going to be exactly the carbon copy of the original one, so it mutates a little bit. And then, but it's also recombines. And recombination means if you have multiple, one or two viruses replicated in the same pig, in the same cell, in the same macrophage, then they exchange generic materials, and the resulting virus is very, very, very different than the previous one. And here we have an illustration for you. So 3 circles, blue, yellow, and red, each representing a different virus, unrelated viruses, right? So 3, if you have farms that are infected with those 3 viruses, those viruses get to the cells, and then you get many different types of resulting viruses. That's going to be a combination, some sort of combination between the genes of those original strains. And that's, if you have a lot of the resulting viruses, if the number here represents the replication capacity relative to the parental strains, a lot of new recombinants or new resulting viruses, they're not going to be very effective at replicating and then transmitting out of the pig to the next one. But some, and then some will have relatively the same replication capacity, and a few will have a really high. It will just be more fit. And then what's going to happen is the pig's going to select the virus that replicates more efficiently, right? It's natural selection. It's survival of the fittest. And then it just happens that the viruses that replicate faster, they transmit faster from one cell to the next, and then from one pig to the next. And that velocity, that ability to replicate faster, is also super well correlated with clinical signs, right? The more macrophages being infected, the more lesions, the more viruses are up in the air, and then that cycles go on and on and on. And so it's not surprising that in Europe, in the Americas, in Asia, every time there's a new predominant virulent virus, it's going to be a little bit more virulent than the ones before. Because again, natural selection is selecting the viruses that just have higher capacity to transmit and replicate.
And Daniel, when we think about what Clayton has just shared with us, when we think about the infection triangle, if we would delete one of the pillars, the susceptible animals, we would have less replication and less recombination, and eventually also less mutation and creation of highly pathogenic PRRS strains, right?
Yeah, and that's a good news about herd, what we call herd immunity. If you have a herd that has high immunity, you can achieve that with a whole herd vaccination, then you just create less opportunities for those wild type viruses to gain, recombine, and find the next and emerge the next strain, right? Herd immunity is the key. And because the virus evolves and you create more virulent strains, it's not surprising that when we do economic studies to document what's the economic impact of PRRS in the system, in the country, those numbers are from the US, right? The numbers keep going up. And the last update was in 2000, maybe a couple of years ago, with data up until 2020. And this data is showing that PRRS costs the equivalent of about $1.2 billion to the swine industry just due to losses in productivity And that's before the emergence of these lineage 1 C viruses. So I was talking with Clayton yesterday. We think that today, just based on the mortality rates we see, that number is going to be somewhere north of 1.2 billion. Not sure if it's quite at 2 billion, but it wouldn't be surprised if it reached that close because of those viruses replicating efficiently in the growing pig and in the sow herd. And that 1.2 billion per year in the US industry is just due to changes in productivity, right? Less efficient growth, higher mortalities in the whole herd, but we can't ignore the fact that it also affects pig care, it affects labor, it increases the use for antibiotics, because just like Marcel was talking about PCV2, right? PCV2 is never alone. PRRS is never alone either. So if you think about PRRS replicating macrophages, macrophages is an important line of defense for the immune system. With impaired macrophage population, what can you expect? Well, more efficient replication of strep suis, mycoplasma, and everything you can think about, right?
Exactly. But the good thing is that we are not doomed. So we do have the tools and vaccines in place to control also these hyperpathogenic PRRS strains. And this is just an overview that quickly summarizes the reduction in lung lesions that we are seeing in challenge studies, and this are referring to peer-reviewed publication. This is a reduction in lung lesions with pigs that have been vaccinated with Engelbach PRRS MLV. So you see there is a cross-protection also from type 1 to type 2. So Engelbach PRRS MLV also reduces lung lesions in PRRS 1 infection by half. And those 49%, those equal, I think, 47 peer-reviewed publications. So this is just the average. And then to break it a little bit down, we have also added the reduction in lung lesions in those highly pathogenic PRRS strains that we are hearing more about in Dr. Clayton's presentation later today. And also, we see a significant amount of reduction in lung lesions when we are talking about the strains that are occurring here in Asia, NADC 30 and NADC 34. And reduction of lung lesions is one part of the story. The other part of the story is mortality and average daily weight gain, which we should also focus on. And this study was published by Greg Haywick already a couple of years ago, and I like it very much. And you may find it a little bit confusing in the very beginning, but I will walk you through this slide, and in the end you will understand it perfectly. So what the researchers did, they compared animals that have been vaccinated and animals that have not been vaccinated. And then they challenged those groups with increasing amount of virus. And now let's take a look at the animals that have been not challenged. So this is our baseline. And the baseline you can see here, this is the dotted line, right? So animals that have not been challenged had average daily weight gain of 760 grams in the study. And as soon as those animals were challenged with a moderate amount of virus, so 10 to the power of 1 wild-type virus, already this low to moderate amount of virus resulted in a significant decrease in average daily weight gain. So average daily weight gain dropped from 760 grams to 560 grams. So this is really a significant reduction in those unvaccinated animals. But when animals have been vaccinated, you see that they nearly reached their genetic potential. So there is only very little reduction in average daily weight gain in animals that have been vaccinated. And by the way, this is this graph here. So here we are talking about, I'm going to show it here. Here we are talking about the 740 grams in animals that have been vaccinated and challenged compared to the 560 grams. But what we can also see is when we are increasing the challenge dose, so this is a low challenge dose, moderate challenge dose still works quite well, but when we are increasing the amount of challenge, then we see lesser efficacy in our vaccination. And therefore, we combine vaccination with biomanagement practices in order to create an environment where you will gain the most benefit from their vaccination, where vaccination can nearly totally mitigate the negative effect of the devastating disease that you are struggling with in your system. And how are we going to do that? You all know the 5 steps, right? So first, we need to identify our desired goal. We have been hearing about in the morning about PRRS elimination, which can be a good program if you apply it, as you heard from Nikolai, on a national level. So the more farms are participating in an elimination program, the more successful it will be. On individual basis, we think that PRRS control is the more attainable goal. As a second step, as we have made up our mind, what is our attainable goal? We need to identify the current PRRS status. We need to understand the constraints in the farm. We need to develop the solution options. And eventually, we will need to monitor our outcomes. Daniel, can you explain us a little bit about how to determine the current status and identify the desired goals?
Yeah, so for the 5-step, like you said, the first step is decide what you want to do, right? Because then that's going to dictate, did my program work, did not work? It's got to be really crystal clear what is your expectation. And to simplify a little bit, we can simplify that question between, am I going to control the virus or am I going to eliminate the virus? Elimination is clear, straightforward. Elimination means it's going to be no virus at all. When you heard an example from Nikolai at the whole country level, their goal is we're going to get rid of this virus. But for a farm that lives in a high-dense area, that may be not the most clever solution. If you can't control what the other farms are going to do, then control may be good enough for you. Meaning, I'm going to live with my herd immunity high, and so I'm going to be living with that insurance from the wild-type virus, building immunity so that I mitigate the clinical consequences of infection. And so at the beginning, I am here, right? I'm unstable. I have a lot of wild-type circulation, and then I'm going to have to choose if I'm going to control. We also call that getting stable, meaning there's no active wild-type virus circulation, but I still have the immunity. So if I have a continuous exposure of the wild-type via shared people, equipment, or airborne infections, then I won't have as big of a clinical impact. And then the other choice is we can go negative if you really think you can keep that negative status for 3 to 5 years or more. Here is data from one large production system in the US comparing their productivity in terms of win-to-finish mortality coming from herds that are either unstable, stable, or negative. So not controlled at all. Then in the control stage and in the negative stage, you could see clearly that if you go from unstable to stable, you have a big gain in reducing your win-to-finish mortality, right, attributable to PRRS. Not so much difference between stable and negative as expected because, again, stable means controlled. I don't have wild-type circulation in that system. How about that 40%, Marius?
It's important that if we choose to be PRRS negative, so if we go the Danish way and eliminate PRRS from our system, then we cannot rely on immunity. And when our farm is breaking, then again with a PRRS strain that are all over the place, we see a huge loss in piglets compared to stable systems.
So if I'm naive and break, I will have 40% more losses than if I'm stable and break again, right? So big difference in numbers there. And in graphical terms, right, summarizing what we said, if you want to eliminate, you're going from a high PRRS activity to zero PRRS activity. So in this case here, you have zero immunity to protect your herds. If you break again, it's going to be 40% more losses than if you're in this situation here, where you're not targeting elimination, but you're targeting control. You're always vaccinating every now and then the sow herd. We can talk more about frequency later. right? You're paying here for you're building your insurance. So when you have encounters with the wild type, your change in productivity is not going to be as dramatic.
Exactly, and this is why we have in the brochure also included the eligible criteria. So this makes really most sense for most commercial production system. And if you're a genetic company, a multiplier, or selected commercial sow farms in very low-dense pig areas, then you can think about PRRS elimination.
So there's no best scenario, right? It really depends on your scenario.
Right, and now we need to determine the current status. And I think from the research, there has been invested so many knowledge, effort, and money into diagnostic research that nowadays there has been not a more appropriate time to do proper diagnostics than today, with all the knowledge that we have acquired through the research that has been done also by with the Iowa State University. And what you can see here very clearly is that there has been a decrease in serum samples. So 20, 15 years ago, serum sample was the standard procedure. Now we are talking about US sow farm data, but nowadays people are relying mostly on aggregated samples. Aggregated samples are cheap, easy, and convenient to take, and this is just quickly depicted here on that particular slide. So when we would have 100 pigs in our barn, and 3 of them are PRRS positive, with serum sampling to detect 1 PRRS positive pig, with serum I would need to take 64 samples. So I would need to sample more of the herd as non-sampled, whereas if I'm gonna choose aggregated sampling, with 1 PCR, with 1 processing fluid sample, I can detect those 3 positive pigs very easily, and I think up to 500 pigs can be included in 1 PCR for processing fluids, right? So if you do this, if you use aggregated sample, and also importantly to do it consecutively, because PRRS is shed intermittently, so you will have a batch that's positive, you will have a batch that's negative, you will have a batch that's again positive. This will be on and off, and it is important to include consecutive PCR sampling, for example, with processing fluids, to be really confident that your sow farm has reached PRRS stability. And in order to do so, you need to be 12 weeks PRRS negative in those samples to really make sure that you have reached the PRRS stable status. And if you are interested about sequencing, you can vote for the jukebox topic from Daniel Linhares about the do's and don'ts of genotyping PRRS, which is a great presentation. I've seen it already, so vote for it. Because sequencing can help you to understand the number of strains that are present in the system. It can also help you to understand the origin of the PRRS strain. So where is the strain coming from? Is it coming from the neighboring farm? Is it coming from another barn in my system? Is it probably also a rebreak? So is this, again, a new introduction, or is this a PRRS strain that has been circulating in my system for quite some time? So therefore, sequencing is very valuable for you to answer these particular questions. And now, Daniel, how about the constraints in the farm?
Yeah, so now we established the goal, so you know where you want to get. Then you establish your current status, so you know you have point A and point B, right? You know where you are, you know where you're gonna get. Now before you draw the plan to get there from A to B, you gotta understand what's in between. What are the roadblocks? And this is what we mean by constraints. And so before jumping too quick on the constraints, just a reminder here of our infection chain, right? Infection and transmission chain could also be called the prevention chain. So how you block the ability for PRRS to jump from one age group to the next, from one farm to the next, right? As a reminder, this is how PRRS moves. Nikolai talked a lot about guilt, so it could be coming from the guilt source. Even if the guilt source is negative, you don't know what happens during the transport of those guilts and quarantine and everything. Then when they move to the sow herd, of course, PRRS can be transmitted down to the piglets directly, right, via the sow, so vertical transmission during gestation, and the virus can also be transmitted horizontally or from one pig to the next or one age group to the next. Then some of the constraints, where we can't talk about all of the constraints here, but we picked 5 common constraints. We're going to talk a little bit about each of those. We selected those because working with different herds across in different regions, we find that those are very commonly applied. We're not saying that you all have those constraints, but those will be very common ones. Biosecurity challenges, labor, pig flow, co-infections, and vaccination, Marius, and we're going to talk a little bit about each of those.
Exactly, that's totally right. So barriers to implement biosecurity, this is based on a publication in Europe where they have identified a common theme in farms that are not implementing biosecurity and the reasons for that. And it is very important that we address, when we're talking about constraints and then eventually implementing solution plans, that those constraints are properly addressed. So the cost of the implementation, knowledge gap, how are the constraints occurring in pig-dense areas? And drivers to implementations are economic benefit with fewer breaks. So as we know exactly how much the disease costs, so we have the data, we have the economics for PRRS, we can quickly draw the economic benefits of fewer breaks. We have tools and clear guidance, and as Nikolai pointed out this morning, collaboration is very important, independent if you're aiming for a PRRS control or for a PRRS elimination program. And the good thing is that we can all address those needs and drivers.
There has never been more tools that, as they are available today, right, to help, so the vets can help the production folks to understand how much PRRS is causing to the system, and therefore put in a simple model, the return of investments of investing in biosecurity should be straightforward.
Absolutely. And the other thing is co-infection, a big constraint that Sergio Mendes, also known as Gustavo Silva, and Marcelo Almeida, right, was talking about this morning, that we see that PRRS and PCV2, they can lead to severe impact in our production system. When both occur simultaneously, as we have learned in our previous presentation, the economic impact is even more severe. And when you are weaning PRRS unstable pigs and then they get infected with PCV2, for example, you see really a huge reduction in average daily weight gain and big clinical signs. So don't only focus on PRRS, also focus on potential co-infections that are making your life more difficult. And another thing that is, I think, very important to highlight, and this is based on the POM data project from the Field Epi guys, they found out that 90% of the farms that are breaking with PRRS, they are breaking with more than one strain. So, and if you happen to have more than one strain in the system, this will also impact your wean-to-finish mortality. And there again, sequencing can be very helpful to understand the number of constraints that are circulating in your system. Potential risks in terms of vaccination need to be addressed as well, and you find this also in the 5-step folder for PRRS and for PCV2, but temperature of vaccination, timing of vaccination, conditions, dosing, and vaccine purity are important factors to take into consideration to really gain the best of your vaccination program. Just be reminded, vaccination storage is important. It is also important that we apply the complete dose, because the effect of the vaccination is dose depending. The less vaccine you are applying, so if you're going below the immunizing dose that is in the bottle, you will lose the benefit of vaccination. And this has been proven all and all over again, that we see higher mortality, lower average daily weight gain in systems or in flows that are not fully vaccinated and therefore not fully protected. And also mixing vaccines that are registered for mixing for example, the BI vaccines, the Boehringer Ingelheim vaccines, they are going through a diatic purification process that result in a non-virucidal vaccine. Those vaccines can be mixed, and just make sure that you are mixing products that are intended to be mixed.
And so now you know where you are, you know where you want to be, you know all the constraints in between, right? So it should be straightforward to make a plan. What do you mean by make a plan is the step 4, is the solutions. So what are you going to do about all of those constraints and get you to your final destination, whether that's stable or negative, right? We've addressed all of those key areas here: biosecurity, labor, pig flow, co-infections, and vaccination. Then talking a little bit about what are we going to do about those 5 major constraints as part of our strategy, right? To achieve our control. When we say biosecurity, there are 2 big areas of biosecurity: the external biosecurity and the internal biosecurity. And so biosecurity is a very complex area, but the good news is that the combat program, it's going to help you to identify what are the key areas for your herd, right? Both in terms of external biosecurity and internal biosecurity. And so based on field data, those are 3 common examples of solutions to fix some of those constraints. For external biosecurity, which is more related to location of the herd and stuff coming into the farm, is a pig transport and the supply chain involving everything from people to transport to feed stuffs. In the internal biosecurity, Marius, you talked about pig flow, right? Nikolai talked a lot about the guild flow, so compartmentalization, making it difficult for the virus to jump from one pen to the next, from one crate to the next, from one room and from one side to the next. And of course, implementing working lines for farm staff so that they don't move back, right, from finishing to nursery or from nursery to the gestation or to the farrowing house.
Exactly. And if you want to use Combat, it's available in your language as well. And we have included a QR code in the document. So you can scan the QR code in the document and then evaluate the biosecurity status of your farm.
What's the cost?
0.
Ah.
So my boss paid for it. So you can buy him a drink later on.
And so studies show that when we talk about biosecurity, it's not just an academic exercise. If we implement those changes to improve your transport biosecurity or your labor biosecurity, the numbers are going to show up. It's going to reduce the number of outbreaks. And reducing the number of outbreaks, what can you expect? Well, you can expect better productivity. Teaser. You wanna hear more about grow finish pressure of infection, right? Because we know that a lot of times, why do sow farms get infected? They get infected because there's some virus in the region. And if you think about a region, there is many more grow finishing lungs and spaces than there are sow farms. And so if you think about controlling PRRS in the sow farm, that means, of course, think about the sow farm, but also think about what can we do to your grow finish to reduce the pressure of infection there, right? We call that biocontainment, and that way reduce the chances of your sow farm getting infected. Examples here for pig flow, which is very common, right? We also refer to that as biomanagement tools. Some five examples here we can think about is documented actions or tasks here that's going to reduce the PRRS pressure of infection within the farm is cross-fostering. Want to limit that, especially when your prevalence is going down. You want to make it hard for the virus to jump from one room to the next. Don't move sicklet pigs, sick piglets, especially from older rooms to younger rooms. You really gotta wean them or make a decision what you're gonna do with them, but don't bring them back to younger farrowing rooms. That's going to help the virus to keep perpetuate the infection in the room. Do the batch farrowing, that the all-in all-out that Clayton was talking about, right? You don't want to make it easy for the virus to be jumping from one batch to the next. What else? When you're weaning the piglets, you want to make sure that you empty that room, block the hallway, and then you don't want people moving in the hallway, right, from one room to the next. If you know that weaned pigs are occupying the hallway, you want to disinfect that hallway before you step in that, because the chances are, if there is still virus in the herd, it will for sure be in that older piglet room. And the co-infection, we talked about that a lot. Just another reminder here that when we talk about PRRS control, it's not only PRRS control. It's PRRS and whatever else that it's in your system. Your diagnosis is gonna tell you that, right? Shouldn't be a guess game. It should be a diagnostic investigation. And so your PRRS control, you gotta make sure that you include your PCV, your parvo, your mycoplasma, and the other relevant diseases, Marius, in your solutions package.
Exactly. So one part of the solution, as we heard, is management, is biosecurity, is pig flow adjustments, and the other part for sure is immunizing your herds to make them less susceptible. And when we are talking about vaccination, this is the vaccination program that we can offer with our combined flexible portfolio. And it's very important, as we heard this morning from Nikolai, to include the gilt source. So start at the very beginning here with a double dose of Engelbach PRRS MLV, usually 4 weeks apart in gilt introduction, so that you're introducing fully immunized, non-shedding gilts. In gestation, we recommend a vaccination with PRRS MLV every 3 to 4 months, depending on the infection pressure in your herd. And also super important to include the growing pig herd into your vaccination program, because what will happen is, if you have not included them into the vaccination program, the pathogens will jump back into your vaccinated herd and cause again problems, also potentially in vaccinated animals. And why this is so important to implement and include them into your whole herd vaccination program. Daniel, let's take a look at this video.
When an unvaccinated pig herd experiences a PRRS outbreak, the virus spreads rapidly. With an R value of 5.4, each infected pig will pass the virus to more than 5 new pigs, leading to rapid spread across the entire system. However, in fully vaccinated herds, the transmission rate is 10 times lower, and each infected pig passes the virus to an average of 0.3 new pigs. This low transmission rate will stop the spread of the virus. The PRRS infection will fizzle out if managed correctly. In commercial production systems, only 5 to 10% of the herd is breeding stock. The majority are growing pigs. When only sows are vaccinated, the infection will first spread extensively in piglets. Because of the high numbers of infected, shedding growing pigs, infection pressure increases and the PRRS virus can jump to the breeding herd, potentially causing clinical signs in vaccinated sows. By contrast, vaccinating both sows and piglets will limit the spread of the virus after introduction, and, if well managed, PRRS can disappear from the system. Vaccination effectively limits the spread of PRRS. Protect your sow herd by applying a whole herd vaccination program and including piglets in your vaccination plan.
And with that, Daniel, we have completed our solutions, we have implemented our solutions, and now it's really time to monitor the outcomes, because only if you're tracking the outcomes, you can verify if you are progressing on a good path, so that you're remaining on the path to controlled success. And how this is going to be done is, again, with diagnostics. So we talked about diagnostics at the very beginning. We're going to end with diagnostics, because the benefit is here that if you are using those samples consecutively, so if, for example, you are monitoring PRRS and you're processing fluids over time, after implementing your solution plans and understanding the constraints, you will see that the amount of virus will decrease over time. And you will see that roughly 20 weeks after the initial outbreak, you will have the first negative results. And if you then implement consistently your solutions and stick to them, you will see that the amount of virus is further reduced up until you have reached a scenario where you have become PRRS stable, meaning weaning PRRS negative pigs. And Daniel, when we talk about the timelines from your results at the POM projects, can you guide us a little bit about what to expect when after the outbreak?
Yeah, so this data here comes from about 600 or so outbreaks, right, from different breeding herds. So it's an average. Of course, you may have farms that are significantly in the lower end or in the other end, but in general, those are the averages we expect. What we know for sure is at the end of the day, they're gonna reach stable, but if they're never going to reach stable if they don't go through these recovery steps here first, right? Meaning, for example, if they still have an abortion storm for several weeks or months later, you don't expect, if the abortion storms didn't resolve, you don't expect that's going to move to the second step here, which is recovery of the number of stillborns and mummies. It's never going to transition to PCR negative. So we encourage you to start monitoring since the beginning of the outbreak, since the very initial weeks, because that's what we expect. Complete recovery in aborts within 4 to 6 weeks post-outbreak. Then once that's resolved, then you can expect the number of your total born to recover by reduction of stillborns and mummies. And then it's going to be about 21 to 26 weeks, so you reach your baseline productivity, meaning no more aborts, no more, the repeats are back to normal, the total borns alive, and the number of wins are back to normal. So about 6 months post-outbreak, you're going to be fully with full productivity already, but still leaking the virus. So and that's a point that we can't overemphasize. There will be a long stretch of time of 10 or more, 20 weeks of subclinical PRRS infection going on, and that's where your diagnostics really are going to help you to understand if you're subclinical with or without wild type circulation, and then your diagnostics testing is going to reveal that, Marius. Right?
Absolutely.
And so what do we...
We were clicking both, so we were advancing the slides both at the same time, but this was that one, right?
Yeah, this is some sort of a decision tree we put together, and this is the simplified version here for you, starting at the beginning, thinking about the infection chain. So we start with processing fluids. Mario talked about that, right? If the processing fluids are still positive, maybe you're in that 20-week mark or 30-week mark, it doesn't matter if it's still positive, but you're not sure if the infection is coming from the gestation herd or if the infection is still just being transmitted within the farrowing barns, then you could do some tongue fluid testing from the dead born from that first and second day of life. Right? If the stillborn piglets are positive, then you know that the infection is actually still active in the gestation herd. So you may want to consider a whole herd vaccination or some efforts to reduce the pressure of infection there. When it transitions to negative processing fluids, it's good news. But as a reminder, Marius talked about that. 1 or 2 or 3 weeks negative are good news, but not enough. Keep monitoring. The current definition of stable by the American Association of Swine Vets is reaching 12 to 13 weeks of consistent negative results, and that's gonna give you confidence that you don't have the wild type circulating anymore, and then now you reach the stable status that you're looking for.
Exactly, and the good thing is that it can be done. So nowadays we have all the knowledge, we have all the tools available to control PRRS if you are aiming for elimination or for PRRS control. And this is just a reminder on a study that has been conducted in Spain. So there was a project where 11 neighboring farms participated on a regional PRRS control project. And overall, it was very beneficial for those farms. So they saw a return on the investment by 12.1 just by reducing the number of PRRS breaks in their systems with using the 5 steps.
It works.
It works. And it works also that you have been submitting so many Slido questions. And now I would like to hand back over to Oliver for the last stretch of the program before we're going to go for lunch.